Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 6C. Myself, Karthik Bharadwaj, and this session would be moderated by me on behalf of Global Knowledge Search Foundation and JR Solistic LLP. It's my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being organized through Zoom from 19 to 21st of January 2026. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for their presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remark. If you have any query or any update, you can write it to me in the chat box. Just before getting started, I'd like to introduce you with our today's session chair, Dr. Hrishikesh Joshi. Dr. Hrishikesh Joshi is an assistant professor in the Department of Artificial Intelligence and Data Science at Vishwakarma Institute of Technology, Pune. He brings over 14 years of combined academic and industry experience and is actively involved in teaching and research in the field of AI and data driven technologies. I request sir to kindly address our participant.
Thank you, Karthik sir. I hope I'm audible to everyone,
Yes, sir, you're
right?
audible to us.
Yeah, it gives me it is my pleasure as well to welcome all the technical to all to this technical session 6C of the 10th International Conference on smart trends in computing and communication SmartCom 2026. This technical session brings together a set of high quality research paper that address contemporary challenges and advancements in smart systems, in intelligent computing, then communication frameworks. I'm confident that the presentations and discussions today will be insightful, thought provoking, and will inspire further research collaboration. So, without wasting much of the time, I extend a warm welcome to all the authors, reviewers, delegates, and participants. I sincerely appreciate your effort, patience, which contribute significantly to this to the success of this conference. So let's have an engaging and productive session. I now invite our we can invite our first session. Thank you very much.
Thank you, sir, for highly motivating words. Now, I request the first presenter of the day, Soumya, for the paper title A Combined Quantitative and Qualitative Survey on the Melanoma Skin Cancer Detection Strategies. I request the presenter to kindly proceed with their presentation.
Good afternoon, sir.
Good afternoon, ma'am.
Yeah,
Now you can share the screen.
Sure. Can you see my screen, sir?
Yes, it is visible now. It is visible.
Yes, sir. Thank you, sir. Good afternoon, everyone. Good afternoon, sir. My name is Soumya, working as an assistant professor in the Department of Computer Science and Engineering, Manipal Institute of Technology, Bangalore. I will be presenting a paper on a combined quantitative and qualitative survey on melanoma skin skin cancer detection strategies. So first of all, I just go with the content, introduction, related work, experimental result, and research findings. Conclusion and references will be including in the presentations. Introduction. Why the introduction? Why is the melanoma detection is important? Melanoma is the most dangerous skin cancer. It spread very fast organs like brain, liver, lymph nodes. If detected early, 95% of survival could be possible. If detected late, then survival drops drastically. So the problem with the doctors use the dermoscopy plus ABCDE rule, which depends upon the experience of the dermatologist Two doctors may give a different opinions. Hence, we need a AI systems in order to identify the consistent, accurate, and that can assist our doctors also. Melanoma is a highly aggressive but curable if it detected early. The traditional diagnosis is like we have seen. Traditional diagnostic depends upon the dermoscopy and the ABCD rule, subjected to and depends heavily on the dermatologist expertise. Here, we'll be comparing and organizing all the AI-based methods used for melanoma skin cancer detection and explain what works well, what does not, and what should be done for the next year. So, here, the data set used in identifying the diseases is ISIC and PH2 data sets and Dermafit imagery library and MedNode and HAM 10,000. Here in the ISIC, more than 75,000 images are used in order to identify lesion types, the melanoma, nevus, and BCCN, different types of lesion classes, imaging the dermoscopic and clinical. And remarks is that largest and most diverse public repository and host annual challenges. So there are the different data sets has been used where images are taken and identified the diseases where it is already shown in a slide. Related work is so most of the traditional machine learning algorithms will focus on manual feature extraction, like they extract color features or textural features or border irregularities. Once the features are extracted, they are immediately fed into the ML classifiers like SVM, KNN, or decision tree algorithms. Where here in the traditional machine learning algorithm, we'll be finding the accuracy with the 75 to 85%, which is interpretable but weak. Where when we go with the deep learning model, deep learning is especially convolution neural network, has predominantly advanced in melanoma detection with the automatic features, learning directly from the raw images. So in the deep learning method, which make use of the CNN, along with that, it uses the architecture like VGGNet and ResNet and the DenseNet, where we get 85 to 90% of high accuracy with the black box. Black box in the sense where we can't fully trace the logic step by step, and how the decision is taken is completely hidden. Some of the hidden features are taken, extracted, and come to the conclusion with the 80 to 95% of high accuracy. And hybrid ML and DL approaches, the convolution which uses the CNN, along with the CNN, will make use of the classical machine learning algorithm, like again SVM, KNN, or decision tree, or the random forest algorithm, in order to classify the results. This role will be separation permits the system to have a maximum use of representation power and DL models. Whereas in this hybrid ML and DL approaches, we used to get 85 to 93% of accuracy, which is balanced. And coming with the next one, this is generative and adversarial networks used in a melanoma detection, generate the realistic and dermoscopic images for both for malignant and the benign skin lesions. This helped to increase the size and diversity of the data sets, especially when real medical images are limited. And it also balances the imbalanced data. It also identifies the diseases from the imbalanced data set. May improve the data heterogeneity, can enhance the performance and reliability of the deep learning models, where in the generative adversarial networks, we used to get a 90 to 94% of accuracy, by which this will be considered as a burst performance in order to identify the lesions on the skins. So explainable AI, which helps the doctor in order to make a decision-making process. So we go for introducing the explainable AI with the explainable AI with the skin detection. Skin cancer detection. These are the methods used, and the advantages and disadvantages are categorized. So here, clinical diagnosis, image-based techniques is used, traditional ML, deep learning, and the mobile or telemedicine tools, and hybrid multi-model techniques, and statistical data and model-driven data-driven models are used. Advantage and disadvantage are mentioned, out of which where the very less used, widely used and less interpret, the low tech equivalent is clinical diagnosis, is independent, where is the clinical and very low sensitive, whereas the highest where if you consider the deep learning, which got a high accuracy, and the automatic feature extraction is possible here, which requires a larger data set and less interpretable, high computational is in demand. And if you go for the statistical and data driven models, transparent, good for explanatory analysis, which gives you the less adaptive, lower performance of the unstructured argument. Some of the methods, their advantages and disadvantages are listed in the slides. Analysis of Analysis of melanoma skin diseases. Melanoma detection has progressed from the manual feature engineering to deep learning and generative modeling, for each offering the distinct strength and clinical relevance. Performance varies widely due to the data set, image quality, and the class imbalance. So this is the analysis which we have made from the existing research, where performance varies widely due to the data sets and image quality, class imbalance, understanding the need of comparative analysis. While the metrics like accuracy, sensitivity, specificity, and AU are valuable, they overlook the interpretability, robustness, and population adaptability. For safe clinical development, both qualitative and quantitative results and failure condition must be assessed. So quantitative analysis and skin cancer detection strategies are the primitive ML models is all primitive. The work has been done on primitive ML models, using the deep learning models, using the hybrid ML-DL approaches and GAN-based approaches. When they have used the primitive ML model, rely on handcrafted features such as shape, color, textures, and border measures, offering the interpretability and low computation cost, but performing poorly on noisy and the diverse dataset. Compared to the primitive ML model, deep learning will give you the automatic feature extractions along with the GPU resources with reduced interpretability. And when we compare with the deep model, the little better model is hybrid ML and DL approaches, which combines the feature extraction for clearer decision labels and suitable for medium-sized dataset, but complex is less scalable. If you have a larger dataset and it is very imbalanced and a very imbalanced dataset, then you can go with the GAN-based methods addresses data scarcity by generating the synthetic sample, enhancing generation through they require heavy computation and careful validations. Compared to all four, the best result got in the GAN-based methods. So quantitative analysis on skin detection strategies are like quantitative comparison mainly influenced by size of the data sets. You can also consider 4 key measures which are taken into the considerations, like classification accuracy, sensitivity, specificity, and AUC. These are the considerations which are taken as a measure in order to identify the quantitative comparison between the different data sets, where the different results has been this different result has been varied according to these measurements. The evaluation is done on IISc HAM 10,000 datasets for the classification, but training the model is computationally expensive. Synthetic images must be carefully validated in this case. This research findings, a summary of the quantitative analysis is, the approaches are listed along with their accuracy, sensitivity, recall, and specific AOC. The traditional ML, which has accuracy of 75 to 85%, deep learning which got a 85 to 90%, hybrid ML and DL got us 87 to 93%, whereas GAN augmented DL got a 90 to 90%. Out of all these approaches, the GAN augmented DL is the better approach, where we get a highest accuracy with a higher sensitivity and the recall and specificity and AOC in the GAN and augmented deep learning models. Conclusion is that this study highlights the evolution of computational method for early melanoma detection, moving from manual feature extraction to the deep learning and generative models. This is a complete survey paper which on the existing paper which I have taken out and sorted it accordingly based on the accuracy, where traditional machine learning methods remains useful for the smaller data sets, and deep learning approaches are higher diagnostic accuracy, though they depend upon heavy on large, well-annotated data sets and substantial computational resources. Whereas the hybrid model in the GAN-based model, which will give you the good performance which addresses the challenges like class imbalance, limited data, and the domain variability, improving the model robustness. The future work can be done by using the federated learning or by classifying on a multi-class multi-class datasets, which are interpretable model designs and evaluation framework that ensures the consistent clinical performance across the varied population, imaging conditions, and the real-world settings. So these are the references which we have referred for the construction. And thank you.
Thank you, presenter. Now I request our respected session chair. Sir, do you have any questions?
Uh, the data set that is ISIC and PH2, right? That has
Yes,
been
sir.
utilized.
Yes, sir.
These are the data sets. So
Yes, sir. Yes.
how huge this data set is?
Come again, sir. Sorry, sir. Could
How
not hear
huge
you.
this data? What is the size of this data set? Is it
Data
your
set is
data
more.
set, or this is what you have just referred this data set?
No, sir. The work is which is already this as it is a survey paper. The work has been already carried out on these data sets.
Okay, so evaluation is based on these data sets,
Ha,
right?
evaluation is based on these data sets.
Okay, all right. Thank you.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. Ma'am, I request you to kindly remove your screen.
Okay. Sorry.
Thank you.
Just a minute, sir. Um,
Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I like to call Ruth for the paper title Academic NLP to VIS, a natural language interface for SQL generation and insightful visualization of educational data. I request the presenter to kindly proceed with their presentation.
Thank you so much, sir.
Ma'am, now you can share the screen.
Yes. Is it visible?
Yes, it is
Yes,
visible. You please proceed. It is
Thank you
visible.
so much. Okay. Good afternoon, sir. Good afternoon, everyone. I am Ruth Diabrio. I've completed my BTech in computer engineering and I'm currently working in Capgemini. So today I will be presenting a work titled Academic NLP to WIS, which focuses on transforming natural language questions into SQL queries and meaningful visualizations specifically for educational data. So this is a table of contents that we'll go through with the introduction. So educational institutions generate large amounts of academic data, but when we analyze it, it often requires technical expertise. So academic NLP to WIS enables users to query this data using natural language and receive automated visual insights. So for proposing this, we've studied a few existing systems. Systems like Advisor, NCNet, and Chat2Wiz show that NLP-based querying is possible, but the limitation here is they are often general purpose, rely on synthetic data, or basically lack domain-specific understanding. We also have traditional tools like Tableau and Power BI, but they also require manual query and chart selection, making them less suitable for non-tech academic users. So the problem statement that we've come across is despite the availability of large educational data sets, effective analysis remains challenging in a way because we need technical skills or we lack the education domain understanding. So existing tools are either too technical or not tailored for academic data. So this creates a need for an end-to-end system that converts natural language queries into accurate SQL and then meaningful visualizations. So academic NLP to WIS is a modular end-to-end framework designed specifically for non-technical users. So the system accepts user questions in natural language. The language we are targeting right now is only English. We have automatically converts queries into SQL statements. It predicts the most suitable visualization type. Also eliminates manual SQL writing. To do this, we've used a fine-tuned T5-based encoder-decoder model. So the workflow of our framework goes as following. We have a structure and sequential workflow that we follow. So we have natural language query input where user questions, or the system accepts user questions written in plain English. For example, a user can give a question, how many students were placed in the computer department in so and so year. Next, we move on to data pre-processing. Since our framework works on real-time academic data, pre-processing was a crucial step because a minor mistake in this could put off the accuracy by a lot. We have the T5 based model, which is an encoder decoder based model, which I've expanded further in the next slide. And last, we have the visualization and insight generation. So the generated SQL query is executed on the data set, and the predicted visualization is automatically generated. So the model experimental setup that we have. So we've used T5 base. The encoder captures a semantic intent that the user questions, and the decoder generates the corresponding SQL query and chart type. The reason why we've used T5 is because it's a text-to-text transformer model, where both the input and the output are treated as text. So this makes it suitable for converting natural language questions directly into SQL queries and chart labels in one unified model instead of using multiple models. So the training configurations are the standard T5 configurations that we've used. So the main focus of our framework is the data set. So we introduced a real-time domain-specific data set called Academic SQL Viz. So we've developed the data set on our own using real academic data from St. Francis Institute of Technology. We also have this data publicly available on Kaggle for any further use. So to give an overview of the data set, we have 3,136 entries, where each entry contains a natural language question, the corresponding SQL query, and the explicit chart type. The chart type that we've explored right now is scatter plot, pie chart, and bar chart. A sample of the data set is shown in this image. So this data set covers basic academic relations like student information, admission data, semester-wise results, placement results, etc. So next, performance evaluation parameter. This system is basically evaluated using standard NLP to SQL metrics. We have the exact match accuracy, which measures exact string level SQL match, where the SQL query is as it is in the result as it was in the training. We have logical accuracy, meaning that even though our output SQL does not match the trained one, the output given is the same. This ensures the usability of the model overall. And we have execution accuracy, which measures correctness of query execution. Additionally, we've also used precision, recall, and F1 score to evaluate our SQL generation and chart type prediction performance. So the result based on this is we found out high accuracy for SQL generation, the exact match being 91.59%, the logical accuracy being 92.92%, whereas we have near perfect chart selection with F1 score 98.56%. So this is an example of the result that we get when a user enters the question, how many students are placed in the computer department for year, example 2022-2023. So the bar chart shows there are 78 students placed. Now, why bar chart for this? One, it's trained on the data set. Second, bar charts are ideal for representing count-based comparisons. So hence the bar chart. We have one more example of pie chart, where the question given by the user is, what is the distribution of students based on pass and fail categories? We have another example for our third visualization, which is scatter plot. The question given by the user is, what is the relationship between CET scores and diploma background of students? So the scatter plot reveals correlation patterns between the CET scores and diploma status. So in conclusion, academic NLP to Viz successfully removes technical barriers in educational data analysis by automating the entire natural language to SQL to visualization pipeline. The system The system achieves a high SQL accuracy, as we've seen, and a near perfect chart prediction, which is the F1 score, while offering strong domain specific understanding. Our main focus here is the educational domain. So, compared to existing tools, this provides a better automation and flexibility around the academic context. So, we have future work that can be done, which includes generating reach or descriptive insights and extending the system towards predictive analysis. We are also planning on improving the complex and ambiguous queries. And if we can also support additional visualization. Since we only have bar and scatter charts, we can move on from then and explore further. These are the references cited. Yes. Thank you.
Thank you, presenter. Now I request our respected session chair, sir. Sir, do you have any questions?
Yeah, nice presentation. Only one question is there. On what
Yes,
basis
sir.
accuracy is evaluated?
Can you repeat?
On what basis accuracy is evaluated?
So we did this. We trained our model. So we have an academy data. We used the T5 model for training.
And this is what you have used this SQL on unstructured databases, right?
I'm get it, sir.
You
As a
have
data.
used this SQL on unstructured databases, I guess.
Yes, sir. So what we've done is because we do not have computation power, so T5 usually requires large computation. So we actually, I'm sorry, coming up with a question, we've used structured data for this. And because we did not have much computation power, what we've done is we use GPU to train the T5 model. And the output that we've gone from this, we've compared to our trained model. So we do not have much scope to actually attain the accuracy. Hence, we've only compared the accuracy from what we've trained and the result that the framework gave us.
You got it. Okay. Nice presentation.
Thank you so much, sir.
Now we are moving towards the next presentation. For the next presentation, I like to call Deep Lakshmi for the paper title Advancement and Barriers in SBOM Generation, a study of public dataset and design issues. I request the presenter to kindly proceed with their presentation.
Yes, thank you so much, Karthik.
Thank you, ma'am.
I'll just share my screen. Let me know once my screen is visible. So
Ma'am, it is visible to us. You can proceed.
Yeah.
Thank you.
Yes. Yeah, hi. Good afternoon, everyone. My name is Deep Lakshmi Babde, and my guide for this research is Khushbu Gurana ma'am, and we are from Sri Ramdev Baba College of Engineering and Management. Today, we are excited to present our work on advancement and barriers in SBOM generation, a study of public datasets and design issues. Let's start by acknowledging the critical challenge facing our digital world today: software supply chain security. As you can see from the slide, our reliance on open source components and third-party dependencies has exploded. While this fuels innovation, it also creates a vast attack surface. Recent high-profile incidents like SolarWinds breach, which happened in 2020, and Log4j vulnerabilities have dramatically highlighted this vulnerability. These attacks weren't just about single flaws, they exposed a fundamental lack of transparency in what actually goes into our software. This brings us to the core topic, which is software bill of material or SBOMs. SBOMs are emerging as a crucial tool to bring much needed transparency, enhance security, and ensure compliance across this entire software supply chain. So what exactly is SBOM? If I simply put, it's a structured comprehensive inventory of all the components, dependencies, and libraries within a software product. Think of it as a blueprint of a software. It details everything from open source packages to proprietary components, including critical metadata like sources, licenses, and version numbers. This transparency offers immense benefit. It also helps the organization track the components proactively, identify vulnerabilities, and assess potential security threats, and streamline the compliance as well. Government and industry leaders are also taking notice of these SBOMs. The US Executive Order 14028 now mandates SBOMs for federal softwares, and agencies like CISA and NIST are also championing their own adoption for SBOMs. Coming towards the motivation, despite these clear benefits and regulatory drivers, the widespread adoption and effective implementation of SBOMs face significant hurdles. Our study was motivated by these four issues. First was inability to accurately identify all the components, especially the dynamic ones, inconsistencies in metadata leading to unreliable SBOMs, challenging with cross-software ecosystem integration, and a general lack of standardization despite existing formats. So these are the literature reviews and key findings. As you can see, in paper 6, B et al. Has investigated study on SBOM design issues, and the dataset used was industry case studies. Whereas in paper number 7, blockchain-based SBOM with AI has been used, and various software supply chain datasets were used. Whereas in paper 8, Kim and Kim explored on deep learning-based SBOM defect detection, and where he used medical device software datasets to improve the defect detection accuracy. So in SBOM generation techniques, to understand the landscape, we reviewed the SBOM generation techniques. As shown in this slide, these fall into four main categories. Here's the table presentation of it. Whereas in static analysis, this examines code and artifacts without execution. So it's fast and automated, great for declared dependencies, but can miss dynamic components and produce false positives. Whereas the second is dynamic analysis. This monitors software during execution. It accurately captures runtime dependencies and reduces false positives, but it has performance overhead and limited coverage based on the execution path. Talking about the third, which is hybrid approach, where these combine both static as well as the dynamic methods. They offer more comprehensive and accurate SBOMs, but come with increased computational cost and complexity. Whereas the last is sorry, AI-driven SBOMs. These leverage machine learning to automate dependency, resolution, and enhance threat detection. They offer high accuracy and automation, but require a very large data set and can also have a black box nature. So available data sets. So we have very limited available data sets on the internet available. And our study also analyzed publicly available SBOM datasets, which are crucial for research and improving generation techniques. So two prominent examples are ChainGuard Dev and Cyclone DX. Whereas ChainGuard Dev focuses primarily on containerized application and provides security-rich metadata, offering high accuracy of container-based dependency. Cyclone DX, on the other hand, is widely adopted open source format with extensive metadata coverage across various industries, making it highly adaptable. Talking about performance parameters, we are planning to evaluate SBOMs on accuracy, in which we will analyze how well an SBOM reflects actual components and dependencies, completeness, which includes all the relevant metadata where licenses, versions, hashes are present or not, precision or false positive, minimizing incorrect dependencies or vulnerability reports, scalability, where we will analyze the ability to handle large, complex software projects, and interoperability tells us about the compatibility with various tools and ecosystems. So this brings us to the key design issues that directly impact SBOM performance and reliability. First, standardization and interoperability issue. Despite formats like SPDX, Cyclone DX, and SWID, a lack of uniformity in their implementation creates significant friction, making it hard to integrate SBOMs across different tools and ecosystems. Second is scalability. Scalability challenges. As software project grows, managing hundreds or thousands of direct and transit dependencies become computationally expensive and complex. Third is security and trust issues. The reliability of an SBOM can be compromised by tampering incomplete records or inaccurate metadata, which includes vulnerability rather than mitigating them. And finally, the trade-offs between automated and manual generation. While automation is fast, it can also lead to many false positives. Manual methods are more precise, but they don't scale. So finding the right balance is crucial between both accuracy and efficiency. Coming towards the solutions and emerging trends, fortunately, exciting solutions and emerging trends are addressing these challenges. As shown as in this slide, we can see advancement in several areas. For security enhancement, we are seeing the integration of blockchain for tamper proofing and cryptographic validation, ensuring the integrity and trustworthiness of SBOM data. To improve the SBOM accuracy, advanced dependency resolution methods, AI assisted analysis, and runtime monitoring are being developed. And for enhancing interoperability, efforts are underway to create unified translation framework and open source management platforms that can seamlessly convert and integrate SBOMs across different formats like SPDX, CycloneDX, and SWID, which I mentioned before. Coming towards the conclusion, in conclusion, SBOMs are undoubtedly a critical tool for enhancing software chain security, transparency, and compliance. Our work has highlighted that while progress is being made, significant hurdles remain in their generation and implementation. So we have identified persistent gaps in dependency resolution, inconsistencies in the standards, and challenges in integrating security technologies. However, emerging solutions involving AI, blockchain, and hybrid analysis offer promising pathways forward. So our goal is very clear. We must continue to refine these processes to ensure that SBOMs become more reliable and comprehensive, ultimately leading to more resilient and secure software supply chains for everyone. We have future scope and direction. Looking ahead, our research point to several crucial future directions. We need to focus on developing automated validation frameworks for SBOMs, enhancing their inclusion in DevSecOps processes, and significantly improving interoperability across all existing formats. Furthermore, optimizing AI and machine learning models will be vital for improving the accuracy of dependency resolvers and reducing false positives. These efforts will collectively drive the widespread, effective, and reliable adoption of SBOMs, strengthening our entire digital infrastructure. Thank you so much for your time, and if you have any questions, I welcome that.
Sir, do you have any questions?
No questions from my side.
Thank you. Thank you so much.
Now we are moving towards the next presentation. For the next presentation, I like to call Sahil Dubey for the paper title Analyzing Construction Project Delays Using Data Analytics. I request the presenter to kindly proceed with their presentation. I request the presenter to kindly proceed with their presentation. Sahil is facing some network issues. Let's move to the next participant. For the next presentation, I like to call presenter Richa Sharma for the paper title Confronting Deepfake Technology with Respect to Legal, Ethical, and Technological Perspectives. I request the presenter to kindly proceed with their presentation.
Hi everyone, very good afternoon to all.
Good
Uh,
afternoon.
I hope, sir, the rights has been shared.
Yes, ma'am, you
No,
can.
it is not yet visible.
Is it visible now?
No,
No,
ma'am.
not yet visible.
Let me see. I hope it is visible now.
Yes, ma'am.
Yes,
Yes.
it is visible.
Right. So the title for the presentation is Confronting Deepfake Technology, Legal, Ethical, and Technological Perspectives. So it is a comprehensive review that has been done by me along with my supervisor and co-authors also. So firstly, it is very important to understand what are deep fakes and what is a rapid growth and what are the key concerns about this. So if I talk about the deep fakes, so it is an AI generated hyper realistic media, so that not only mimicking the real person's appearance and also voice using generative adversarial networks. So like if we can talk about its growth, so it has been increasing and it is accessible to most of the people nowadays. And the key areas that we need to focus on is there is a concern about the privacy, reputation, misinformation, democracy, and national security. If we can move ahead with the deep fakes, it is a growing global concern. Like how? So deep fake technology not only represents a significant shift in how digital content can be manipulated. So unlike the traditional images or video editing, deepfakes are advanced AI models to create highly convincing and realistic media. So this realism makes it increasingly difficult for individuals to distinguish between authentic and to get the fabricated content. And somehow it is threatening trust in the form of like digital information ecosystems. And so if we talk about its legal gaps and regulatory challenges that nowadays we are facing about it, existing legal frameworks like defamation laws struggle to address the unique challenges that has been posed by deepfakes. So there are various regulations that are often reactive and limited in scope. And if this study highlights majorly on gaps that exists in the real frameworks, traditional laws related to defamation, privacy, misinformation, and there is so much inadequate to handle the speed and the scale at which deepfakes can it is spreading. So while there are some countries, so they have put some kind of regulations and enforcement, and sometimes it remains inconsistent. So there is a call for adaptive deepfake specific legal provisions and like strong cross border regulatory collaborations to remove these gaps so that these kind of things can be removed. So, if I talk about the social media platforms and how they are collaborating or how they are sometimes it is leading to the misinformation to the consumers. So, social media platforms they act as a primary distribution channel for deepfakes. So sometimes like there are various platforms like Facebook, Instagram, WhatsApp, X. So they have implemented certain policies to limit manipulated content. Most responses they remain inactive, reactive. The discussion emphasizes the need for proactive detection mechanisms. Clearer content moderation policies have been done, and greater accountability from these platforms. We are still there are certain like these platforms they are still waiting for the greater accountability from their side. Now comes the technological solutions for defect detection. So how these like technological advancements they can help in minimizing the or mitigating the risk of this deepfake, and how we can detect the deepfake at an early stage. So AI based detection tools have made certain progress. like certain various initiatives such as DARPA, that is Defense Advanced Research Projects Agency. So they have started doing the defect detection challenge, and real time detection. It remained a challenge due to the rapid improvements in the defect generation techniques. So the discussion, it somehow put an importance of continuous innovation in detection, algorithms, and multimodal approaches. So, before we go ahead, it is very important to understand why there is need for media literacy and the public awareness, because citizen is the one kind of thing they needed to be much more aware about these kind of things like happening. So I think it is the responsibility to get these people aware and literate about all this like deep fake videos or mimicking these kind of images. So consumer awareness, it is again it plays an important role, and educating users on identifying manipulated content and promoting critical media consumption, so somehow it can significantly reduce the spread of misinformation. And it will also initiative, so digital literacy, it initiates, it can also complement some kind of technological and legal solutions around the surroundings also. So, and if the next one is to like how deepfakes are there in advertising and like political communication, there are various ethical concerns that are there in our surrounding, and identity misuse, privacy are central to the deepfake debate. So the discussion, so this study, they basically highlights the importance of informed consent and responsible artificial intelligence use, how we can use artificial intelligence in a proper way, in a proper method also. So there are certain guidelines you should evolve alongside the technological advancements to prevent such kind of misuse, and which is also allowing innovation. So there are certain future scope of research. So the study suggests future research in areas such as real-time detection, cross-jurisdictional legal frameworks, longitudinal perceptions, ethical considerations, industry-specific applications, cross-jurisdictional studies. And somehow so these collaborative efforts between policymakers, technologists, and educators, so these are essential to effectively address deepfake related challenges that are arising in the market. So the overall, if we talk about the overall the conclusion, so overall interpretation about the study would be like the discussion not only concludes that deepfakes are not merely a technological issue but a socio-technical issue, and it is a challenge. Addressing their impact requires an integrated approach combining raw technology, ethics, platform responsibility, and public education. Thank you.
Thank you, presenter. Now I request our respected session chair, sir. Sir, do you have any questions?
Deepfake, even though it looks very simple word, but it is, I know it is a very vast, very huge subject actually. What is the motivation to select this topic actually? And have you implemented any cybersecurity concepts in your project?
Not cybersecurity, sir. I have not used it. The
Mhm.
main motive of using this deepfakes for this as a topic is to because because I'm also doing PhD from Lovely Professional University, and my topic is somewhat related to the social commerce. Social commerce means like various platforms like Facebook, Instagram, and the people they are using these platforms for their shopping
Correct. So are
purposes.
you using real time data sets from X? Previous we can talk about Twitter. Are you using this sentimental analysis in this?
So not for this study, but yes, for my thesis work, I have collected the data on from like different internet users or the social media platforms they are using it, like from Facebook, Instagram, WhatsApp. So I have used like that data, okay, like on what basis these people they are using it, and how frequently they are going for any kind of shopping from these sites. So yes, for my study, I'm using it.
Okay, got it. Yeah, thank you. Nice
Thank
presentation.
you. Thank you so much, sir. Thank you.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Jyoti for the paper title Designing a Collaborative Learning Scheme for Non-Co-Located Datasets. I request the presenter to kindly proceed with their presentation.
Good afternoon, sir. Am I audible?
Yes, sir. Yes, ma'am, you're audible.
Okay, I'm going to share my presentation. Just wait.
हेलो हाँ बच्चे
Yes.
केएसबी हाँ 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 मैं करती हूँ यार मेरी ना प्रेजेंटेशन थी बस अभी खत्म हुई है तो
So
मैं
somebody
करती
is
हूँ हाँ
there.
ठीक है
Somebody is talking at the background. Yes. Sir, is it visible? Are my slides visible?
Yes, ma'am, you can proceed.
Okay. Thank you so much. Yeah. Good afternoon, everyone. Myself, Jyoti Bangre, along with my co-authors, Dr. Nilesh Sabe and Dr. Parikshit Mahalle. My title of the presentation is Designing a Collaborative Learning Scheme for Non-Co-Located Data Set. Paper ID is 479. So during the presentations, we'll be seeing abstract introduction, motivation, problem statement, literature survey, proposed methodology, experimental setup, results, discussion, conclusion, and references. So just a sec, sir. Uh, 1 second. Yeah. Okay, so introduction is IoT, edge computing, and distributed system generate geographically dispersed data. Centralized machine learning is limited by privacy regulation, bandwidth constraint, data sovereignty. Federated learning enables the decentralized training but faces the challenges of non-IID data, client drift, stragglers, and partial participation, high communication overhead, security, and privacy attack. These challenges reduces the conversion speed, scalability, and robustness in the real deployment. So motivation and problem statement. So as I said, motivation for this work is modern data is distributed across geographically isolated nodes like IoT devices, cloud-based system, and centralized machine learning is impractical due to its rules and regulations and because of bandwidth limitations. So data heterogeneity and non-ID distributions are there. So federated learning allows the training without sharing the raw data, but faces challenges of slow conversions under non-IID dataset, high communication cost, vulnerability to privacy attacks. So federated learning allows the training without sharing raw data, but faces challenges of slow conversions on non-IID dataset and high communication cost. So problem statement. To design a collaborative training of global model W across N clients without sharing the raw data, and challenges are non-IID data sets, partial and asynchronous participation, communication overhead, privacy risk. So in our proposed approach, we are using adaptive aggregation, which is a dynamic client waiting to handle the non-IID data set, gradient compression and asynchronous update to reduce the communication cost and improve the conversions, privacy preserving layer for secure aggregation and differential privacy. So this is the literature survey. So during the literature survey, we have referred more than 20 papers, but out of that, couple of papers I have noted down on the slide, which are recent ones. So the research gaps which are come across are no integrated framework for privacy and compression aggregation, no unified solution for non-IID or synchronous privacy compression, extra communication overhead is there, synchronous operation is issue. So communication heavy and limited privacy. So these are the general research gaps has been found out from the earlier paper. There are advantages also. which also we have been referred for the baseline or benchmark. So next is propose system architecture. So during after discussing all these things with the guide and the supervisor also, so we have come up with the proposed system architecture, which is composed of the client and the server. So there are two components here. So on the left hand side, we can see the clients like edge devices. So there are n number of clients are attached along with the central server, that is a server aggregator. So we can see that the data residing at the local data. So that means data will be available at the local end devices only, and it will get trained on the local data set. So whatever local training is happening here, and after computation of the updates, so it has been compressed, like gradient compression is applied and encryption is also applied there, so that the communication cost will be lesser and we can send the model updates in a easier fashion. So after that, so compressed privacy protected update are sent to the central server from all the clients from here, as it is a privacy protected because encryption is applied here. So after receiving at the server side, central server, so there are four components are here. Adaptive weighing is the first one, which is based on the data size, reliability and quality of the data. B is secure aggregation, which is encrypted updates. C, after that is asynchronous update. Q, that is immediate integration. So whatever updates are coming from the client, so server is not waiting for all the client to send the updates. So it will be immediately done. It is asynchronous update. Then after that, global moderate update will happen. So after aggregation of the gradients and optional DP noise, which has been added as a differential privacy for the security reason to avoid any attacks. So after that, the model whichever is been updated, which is a updated global model, again that is sent back to the clients. And again, the same process will continue, the same cycle will continue till the moment we will get the same values after so many iterations. So this is the proposed architecture, which is having more secured and which will reduce the communication cost and which will provide the methodology like adaptive weighing. So this is our proposed architecture. So as I said, in proposed architecture, there are two parts. One is client server. Second thing is that on the client side, local update computations are happening, gradient compression and privacy is there, adaptive aggregation or synchronous update and model redistribution, which is again sent back to the client. These are the general steps for the proposed architecture. In asynchronous versus synchronous timeline, if we see here on the upper side, it is federated average. And on the bottom side, it is a proposed timeline of the our architecture. So in federated average, generally what happens is that central server waits for all the clients to send the update. So this is the ideal time it is required, because sometimes the client works on the update faster. Sometimes the clients are little slower because the data is heterogeneous, so it will take time. So this is the ideal time which is required in between, and because of that it becomes slower. And in the proposed one, it will not wait for all the clients for the updates. So whichever updates has been, let's say 100 clients are there, out of that 30 clients are approaching, so all the 30 will be considered. Rest of the clients will not be considered in that case. So whosoever come first with the updates will be considered. That is why the proposed architecture is faster. In experimental evaluation, if we see the objectives for that is, of course, improve the accuracy, conversion speed, reduce the communication cost, validate the asynchronous learning under partial participation, access the privacy robustness. So the baseline algorithms, what we have referred is federated average, federated procs, scaffold, centralized training is required. Dataset models are the dataset what we have considered from the Kaggles are MNIST, CIFAR. So MNIST, it has been distributed across 100 clients, 2 to 3 clients per client. We have considered classes per client. We have considered 2-layer neural network is there. CIFAR 10, again 50 clients, it has been distributed, which is Dirichlet split with these values. And synthetic non-IID dataset for 20 clients with linear regression of 1,000 samples per client. So implementation details, if we consider here, so it is implemented in Python, and TensorFlow simulator we have used here. So adaptive aggregation weights, that is plus minus 20% has occurred. Gradient compression top 5%, 8-bit quantization. Asynchronous update, if we see here, staleness aware. Privacy, secure aggregation and client level differential privacy with 2 and 10:5 value. Evaluation metrics, what we have considered here is test accuracy, regression loss, conversion speed, communication cost versus federated average, robustness to participation rate, privacy like membership inference and differential privacy accuracy loss. So these are the evaluation metrics. Comparison, if we see here, the existing federated average versus federated prox and proposed method. So in the proposed method, we have considered all these factors like whether it's handle non-ID data, so client drift control, client participation, stragglers tolerance, communication cost, gradient compression, conversion speed, accuracy, privacy protection, robustness to attack, scalability, and real-world suitability. For all these parameter, if we quickly just compare here, so proposed method gives us the more value, like it's strong, it's having adaptive weighing, yes, it is asynchronous per participation, partial participation, it is having tolerance level high for stragglers, it is having low communication cost with 40 to 60%, it is faster, it improves your accuracy, which is higher, 9 to 10, 12% improvement in the accuracy with respect to federated average. It has a high scalability and it is recommended for the real world suitability. So results and discussion. So on the left hand side, we can see the accuracy versus round graph. So in that, if we could see, so the green line shows the proposed scheme, what we have implemented. So there, after 120 rounds, we are going to get here 81.2% accuracy, which is 10% higher than the federated average and federated prox. So federated average here is having 72% and federated prox is having 75% of accuracy. So our proposed system has more accuracy with respect to the existing methods or algorithms. Robustness to low participation, if we could see here, it is higher with respect to the proposed scheme accuracy, which is more than 91%. And whereas for the federated average, it is around 88% or 87% like this. Again, comparison of the methods on the communication cost and accuracy. So method, as I mentioned on the left-hand side, federated average is having high communication cost and its accuracy on the CIFAR database is 72%. For federated prox method, communication cost is medium and final accuracy is 75%. Scaffold, it is communication cost is high and accuracy is 78%. Proposed scheme and proposed methodology having the low communication cost and final accuracy is 81.5, which is the highest one as compared to the baseline models. Then privacy and security evaluation, if we could see here. So in that graph also we can see that on CIFAR 10 model accuracy is decreased from 82.5% without differential privacy. So with differential privacy, it is going to be 81.5%. So it is getting degraded by 1%, but it's completely fine because it will be more secure because of differential privacy. So, and here also after differential privacy plus secure aggregation also, it is having the same accuracy 81.5%. So that means differential privacy protected model reduce this advantage to approximately 1%, rendering that attack is nearly ineffective, any sort of attack, whichever is going to happen. So conclusion is proposed collaborative learning framework for non-collocated privacy sensitive distributed data combines the adaptive aggregation, gradient compression, asynchronous update, and privacy preservation. It achieves 9 to 12% higher accuracy, 40 to 60% lower communication cost, and stable conversions under non-IID data and partial participation. It demonstrates the strong scalability, robustness, and real-world applicability. Future work can be decentralized aggregation, regression, learning-based scheduling, learn compression, and theoretical analysis. These are a couple of references, what we have referred for this research work. Thank you. Any questions, sir?
Very nice presentation, especially experimental evaluation slide is very good, even though result and discussion slide is also good.
Thank you so
Very
much.
nice, very nice presentation.
Thank you.
Only one thing is that you can fit somewhere edge computing, role of edge computing of
Okay.
your project.
Okay.
That's
I
it.
could have, yes, sir. I could have added that because of time limit. I couldn't add much of the slide. I have made certain slides, but I have kept it in different presentation. So because of the time constraint, I have not added, but I'll surely take your point and I will surely add it.
Okay, no problem.
Yes, sir. Thank you so much.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I'd like to call Christabel for the paper title Fake News Detection System Using Deep Learning and Web Scraping. I request the presenter to kindly proceed with their presentation.
Thank you, sir. I'll just share my screen 1 minute.
Yes, ma'am, you can proceed sharing your screen.
So, a very good afternoon to one all present here. Our topic is fake news detection system using deep learning and web scraping. Myself, B. Christabel Johanna, and along with me, I have my co-author, which is Devi Bala D, in this meeting. When we got this topic, we had a few confusions as to what we need to give it back, what to give, because in this era there are a lot of people who are facing issues of not understanding what is true, what is fake. The social media is buzzing with a lot of newses, whether through news channels or other entertainment channels, but we are unable to find the difference between true and fake. So when we went about it and we searched the net, surfed the whole net to understand how to differentiate it, we had a lot of theories that came up, like LSTMs, we had and other deep learning techniques. So first, when we came through our LSTM, we thought we'll first try it along LSTM, but then it didn't understand the sentiments. It couldn't understand the relationship between the other words in a sentence. So we wanted to go down a little further, and that's when we thought deep learning techniques would be a best suit for our project. So our project objectives are quite simple. So we wanted to understand how it is affecting the community and how we can change this issue, how we can give a much better application to people to understand what is true and what is fake. So basic objectives are where to give a system where they can copy paste an article or content from any social media to understand if the given news is true or fake, depending upon the current the sentiment. I'm sorry, I can continue.
Yes, ma'am, you can continue.
So this was not the only issue. When we went through the net, there were like fake news detections for every language. It was all separate. They didn't have it all in one stop destination. It had for Spanish, it had for French. So we aimed that why should people go search for each and everything in a different website when we could all bring it all together. So that is something we felt it was important to be included in our application. Next up was that some articles are found to be long, which can't be easy to copy paste the whole thing, which is time consuming. So we thought extracting from URLs from web scraping would be a much better option, so that it would it would consume less time, and it is fast and reliable also. So our thought was to provide a robust analysis. So we formulated an application which consists of text, URL, as well as image and video. Image and video is something that we are still working on, because we have laid the foundations for it using vision transformer models, but we are still working on to get a much more reliable and fast analysis. So methodologies that we have undertaken were to first we collect the data through image through text, URLs, and then pre-processing it, text cleaning it, tokenizing it, so that it is easier to read. When we first tried our data through LSTMs, few were found to be accurate, but when we try the same article again for the second time, it gave us a different result. So that's when we understood that analysis, there was something wrong with the analysis. So we wanted to understand what went wrong there. So the sentence there couldn't understand the sentiment along with it. It couldn't understand the relationship with the other words, that the whole sentence at one time it read properly, but the next time it couldn't understand the relationship again. So there the accuracy was not correct. it was not durable. So that's when we dug deeper into BERT. So BERT consisted of a lot of parameters which couldn't be used because it was fast. It was very slow compared to distal BERT. It was very slow because it had a lot of parameters to take in. So distal BERT is something which is the compressed version of BERT, but then it is faster and much reliable compared to normal BERT. So the parameters in distal BERTs, a few of them are a word embedding and attention layers, feed forward networks. So the main point in feed forward networks is that they understand, they apply non-linear transformation to the attention output. They help in learning complex linguistic patterns. That is, they first apply a first linear feature where it calculates the input into weight plus the bias. And based on that, it is again sent into an activation layer, which is a non-linear learning, which compares the maximum of the current and the previous one. And again, it is sent into a linear comparison, so that it is revised, so that it again understands whether the previously computed result is true or correct. So supporting components in some few where in distal BERTs were residual connections, layer normalizations, and dropout. So I will talk more deeply into that in a few more slides. For right now, we did feature extraction through TF IDF, which is term frequency inverse document frequency. Like I said, it helps to understand the relationship between the words for easy computation. And VIT is a visual feature which was taken to which splits the image into patches, processes them using self-attention. Model training for text classification and URL were performed through distal BERT, so that it understands the sentiment of the sentence. It helps to understand whether the sentence speaks of fear, sarcasm, or bravery. So some advanced features that we have undertaken in these methodologies were fast checking, credibility score, and multilingual support. Our main focus was to provide a site which is easy for anything to be accessed by users. Whether it's multilingual or image or video is something we want to bring it all in together, so they don't have to go lurking for something else. So some of the evaluation metrics that we have undertaken were accuracy, precision, recall, F1 score, ROC, AUC, ablation study, calibration, and inference efficiency. So this ablation study is something that provides how accurate whether a component is to the study. If based on this ablation study, we will know which feature it's making it unique, which feature is able to analyze this sentiment and give out a required answer, a required output. This calibration measures how reliable the model's confidence scores are. Inference efficiency helps to understand how fast and resource efficient the model is during prediction. So deployment, we build a website which has multilingual support, and image and video in the future, and outputs whether it's a fake or true with confidence, and explains how it is durable. So this is our architecture that we had formulated for our project. So the first image shows how it has all been put together as a one application, whereas the image on the right shows how the user text input, how the extraction, how the cleaning process is undertaken. Okay, so model description. We first prepare the data. When we had the true fake data base, there were many anomalies that we had faced. So we went about, we cleaned the data, we pre-processed it according to the requirement. If there are any odd numbers or which wasn't adding up, we went in, we studied it to understand what was the mistake in there. Then we made a a comparison between logical regression random forest, because we wanted to understand how it is working in relation to other models, so that we get a much more clearer view on how it is working. And that's when we found that
Sorry
these
to interrupt, ma'am, but you have 1 minute to conclude.
Okay, thank you. We used distal bird classification. Distal plus classification also use sentiment analysis, where it tokenizes it, and it is sent into an analysis which sees if the text polarity, whether it's positive, negative, or neutral. So in VIT is a vision transformer, which divides into patches, and each is vectorized, and it is seen in global relationship with the other images. So then web scraping, we as usual, web scraping, we perform through an URL. It has been scraped and the whole content has been read. So that's about it. Thank you so much. And there's this performance analysis that I wanted to show, from the analysis that we had made through the models that we did. So this is that, fake and true and its accuracy.
So this performance analysis is done on what distal bird, right?
Yeah, yes, sir.
What are the major parameters for this distal bird?
So major parameters were token embedding, position embedding, sir.
So these are the URLs, or these are the directly online data sets?
So these are online data sets. First, we made an inference using a Kaggle data set. Then we ran it over the Stanford sentiment analysis to get a further, more deeper knowledge on it. So that's when we understood how much more reliable our data sets must be. So we made it.
Okay.
We made the required changes to it.
Okay.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call presenter Prithvi PM for the paper title Lend Vigil Agentic AI for Loan Recommendation and Privacy Risk Assessment. I request the presenter to kindly proceed with their presentation.
Thank you, sir. Am I audible?
Yes, sir, you're audible to us.
Is my screen visible, sir?
Yes, sir, your screen is visible.
So today good evening, everyone. So today I'm here to present our project, LendVigil, Agentic AI for Loan Recommendation and Privacy Risk Assessment. I am a final year BTech student studying in St. Joseph College of Engineering. Today I'm here with my co-author Sanjay. Mrs. Divya P is our project guide. So today I'll be presenting abstract, introduction, methodology, results and discussions, future enhancements, conclusion, and references. So moving on with the abstract.
Sorry to interrupt you. Can you present this in presentation mode?
Yes, sir.
Yeah, it is visible.
Yes, sir. So in today's digital world, getting loans is has become very easy. People get online loans, and the process of getting loans is getting easier. But there are a lot of risk in getting online loans. It may be formal or informal source of loan, where informal sources have very high rate of interest, and we don't read the terms and conditions often. So people without much knowledge about it are often scammed, and their privacy is in risk. So we present LendVigil, which detects fraud and analysis the terms and conditions. It also introduces a loan feasibility score to rank the loans. So challenges faced by loan applicants. It is very difficult to compare different loans provided by various banks. Different banks provide loans at different interest rates based on our age, credits, CIBIL score, etc. So it is highly exposed to fraud and fake loan offers. People don't know whether their contact details or other apps have been misused by the lenders. The limitations of existing platforms is that there's no integrated fraud risk assessment. Privacy and terms and conditions, they are not being read, or there isn't any tool or app to check whether it uses any hidden things to check the to use basic scammers. So the motivation of this is to for an intelligent system that recommends safe loans. A requirement to detect fraud and privacy threats earlier. So this is our methodology architecture diagram. So the user submits the loan details to the loan recommendation agent. The loan recommendation agent consists of the loan data, which is downloaded from Kaggle. It contains around 15,000 records. 2 lakh records. So it predicts the loan, and the top n loans are given to the user. It is then ranked. The ranked loans are given to the fraud detection agent. The fraud detection agent uses the RBI trust list, which is a data set provided by the RBI for various banks and non-banking finance companies, and it is checked whether it is a trusted company or not. Then it is given to the privacy risk assessment agent. It uses the terms and screenshot of the terms and conditions and checks whether if they are asking access to contacts or any other apps. It is then given to the reporting agent, where it uses explainable AI to explain the visualizations and predictions and outputs to the user. So this is the flow of the loan recommendation agent. The data is pre-processed. The important features are extracted, and the ML-based loan ranking is carried out, and result filtering is done. It is the top n loans are given to the user. Next comes the fraud detection agent. The fraud detection agent consists of loan data given by the RBI bank, which includes banking and non-banking finance companies like Bajaj, Mahindra, like that. And the important features are selected. Next comes the fraud probability estimation. Random forest is applied to find the probability, and it is given as low risk or high risk, moderate, critical, like that. And then the fraud scores are sent to the loan recommendation agent. Next comes the privacy risk analysis agent. It uses OCR extraction to extract the text from the image, then clean and tokenize the text. Uses clause classification BERT. We use BERT because it captures contextual meaning better than any traditional NLP models. Then comes the risk scoring, and the privacy insights are given to the reporting agent. The report generation agent, it aggregates all the outputs given by the 3 agents, and it goes to the visualization engine, where we can view the result in form of graph, tables, etc. And it is given as a PDF, and we can download it, and the final PDF is given to the user. The results and discussions. For loan recommendation, we got an MAE of mean absolute error of 5.75, and RMSE, root mean square error, 6.65. And for fraud detection, we got accuracy 88%, precision 93%, recall 83%, and F1 score 87%. So in future enhancements, we are planning to include federated learning, because even in this there's a possibility of data leakage or anything. So the data is locally processed and only the updates are sent to the central server. Community-driven knowledge graphs can be used, where common pattern in fraud can be viewed earlier. Then an AI-powered chatbot for real-time guidance. Using the chatbot itself, the user can enter all the details and not manually, and the chatbot itself can perform all the tasks autonomously of all the 4 agents. Then device level behavior analysis to detect suspicious loan app activities. So concluding, LendVisual unifies loan recommendation, fraud detection, and privacy risk assessment in a single platform. Agentic AI and enable NLP safe, transparent loan decisions are given. Adaptive learning and expanded data sets will improve personalization and accuracy. So LendVisual not only focuses on whether a loan is affordable, but also whether it is safe, legitimate, and privacy respected. Thank you.
Thank you, sir. I request our respective session chair, sir. Sir, do you have any questions?
How many agents, Arthur, can you please tell me how many agents you have used?
There are totally 4 agents, sir. One is loan recommendation agent, fraud detection agent, privacy risk assessment agent, and reporting agent.
Okay. These are externally included, or you have built all these agents?
We have built, sir.
You have built it.
The outcome, yes, we have built it, and the outcome of all the agents are calculated using loan feasibility score. So that score decides whether the loan is risky or not.
Okay. That's it from my side.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Gaurav Kumar for the paper title Smart Plant Health and Care Assistant Using Machine Learning. I request the presenter to kindly proceed with their presentation. I request presenter Gaurav Kumar to kindly proceed with their presentation.
Am I audible to you, sir?
Yes, sir, you are audible to us and your screen is visible to us. You can please proceed.
Thank you. So I'm Gaurav Kumar and I'm gonna present my presentation on the smart plant health and care assistant using machine learning. So our problem statement is nowadays farmers are struggling with timely detection of plant disease, overwatering and watering under the rainy seasons, like improper fertilizer management, manual monitoring is so much time consuming.
Gaurav Kumar, sorry to interrupt you, Gaurav Kumar. Please can you please do this in presentation mode? Presentation mode, please. Please be fast because we have time limit. Okay, you may proceed, Gaurav. Gaurav Kumarji,
Yes,
you
sir.
please
Thank
proceed from slide number 2.
Thank you, sir. Our problem statement is today farmers are struggling to find the what disease the plant is infected. So we are developing one machine learning models to identify that, and we have included also like plant identification system and fertilizer management system and watering system. Like So our project overview is we are developing one platform that includes machine learning models and AI tools uh, that will identify the disease and plants, and it will give the suggestion based on the disease what we can do to protect that. So we did some literature survey, and here's I have included some main titles and papers details. So our we got to know that existing systems and limitations. So currently, every system which is present in market, they are dependent on API, and they have limited disease which they are identifying, and there is no any automation in watering and fertilizing system. So and any they are not dealing with any real time data. So our proposed work is we are we are developing one system where we are including all of these things, and we are
Gaurav
including
Kumar, Gaurav
AI.
Kumarji, Gaurav Kumarji,
Yes, sir.
we can see only literature survey slide. Are you on a next slide?
Yes,
Can you
sir.
please confirm?
Yes, sir. I'm on proposed work slide, sir. That is
We cannot see that slide.
okay. Let me share once again. Whether my screen is visual, sir.
Your screen is visible, but we can see only literature survey slide. Literature survey slide is in front of us.
So
Maybe
now,
I'm.
sir,
You
whether
please
it's changed or
close.
not, sir.
No, literature survey slide is visible. Uh, Rest of the presentation mode slide or any other slide, you please close it out and stick to this slideshow.
Okay, sir.
Okay, go ahead, go ahead. Okay. Objectives.
Okay, sir.
Please explain.
Yes, sir. Our objective is to identify and detect the disease, and second thing we are doing is to identify the plant species. So next thing we are doing is we are monitoring the growth of the plant, and again we are doing the watering and fertilizer scheduling. We have includes front and back end using technology used. We are using HTML, CSS, JavaScript, Bootstrap as front end, and in backend we are using Flask, Python, machine learning models, database. We are using online database, cloud-based, Supabase, and we have included Gemini. Our key features is we are currently we are identifying 15 plus diseases, and our machine learning models for plant identification is we are using currently custom models, and we have added some fallback system also. So in
Is Gaurav Kumar audible to everyone?
we are using OpenCV
No,
weather
sir.
detect
Call
weather
was
based
starting or
smart weather,
lagging in
and
between.
give the it will it will give the current suggestion based on current weathers, and suppose it's raining means it will auto mark the plants to be watered like that. And we are also giving fertilizers recommendation based on NPK ratio. So our methodology and architecture is user will first upload the pictures, and our AI models will check the pictures and whether it is infected or not. Specific, Gemini will give the suggestions and watering, and the auto water will work and it will show on dashboard. Who will going to use this? For it will be useful for farmers, home gardeners, nurseries, electricity, and in future we can integrate the IoT system also for the auto watering systems. Market potentials and business models. Market potentials: farmer, nursing, uh, gardeners, scalable to large farms and small home gardens. Business models: subscription plans, IoT-based integration in futures. Outcome is high accuracy in detecting 15 plus plant disease, automated water reduce manual efforts, optimize fertilizer using for healthy plants, real-time care suggestion improve plant health, scalable solution for agriculture and home use. And conclusion of our project is smart. It is web-based solution, so anyone can use it, and we have developed a user-friendly interface, so user will easily access all these things. So it is super easy to use our web page, and references is. Thank you, sir.
Inspector Sanjay sir, do you have any questions?
Gaurav Kumarji, there is a lot of scope in a literature survey, as it is a huge this domain has a huge potential.
Yes, sir.
The topic you have selected is very good, but there is a huge scope. Understand this, there is a huge scope in this domain. Okay,
Yes, sir.
I don't know how many APIs you have used. You have just mentioned Google Gemini. For what
Yes, sir.
purpose you have not mentioned it, but that should be clearly mentioned in your slide or in your explanation. Okay,
Yes,
that's
sir.
it
Yes.
from my side.
Thank you, sir.
Which data set also? What kind of data set? Which data set you have used for which crop, for which disease? That is what that should be present in your presentation. Okay, that's it from my side. Thank you.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Akshay for the paper title Unpacking Trust in UPI Micropayments, a techno-behavioral perspective on Gen Z users. I request the presenter to kindly proceed with their presentation.
Good afternoon, sir. Am I audible?
Yes, ma'am, you're audible.
Okay, sir.
Please proceed.
Good afternoon, everyone. So today we'll be presenting our paper, Unpacking Trust in UPI Micropayments, a techno-behavioral perspective on Gen Z users. And the first one is the abstract. Firstly, our main idea of presenting this paper is we have studied on how trust is broken into smaller factors, which is easier to understand, and also how Gen Z users are mainly using this platform. And here, the study looks at both technological factors and the human behavioral factors. So here, this study is formed based on Gen Z users in India who use the UPI platform for micropayments, And this study uses two methods, which is the ISM, which means the interpretative structural modeling, and the Micmac analysis. So these help to identify the relationship among the 10 trust determinants which we have used. And also here our main finding is that the regulatory assurance and the security mechanisms act as enablers, trust enablers. So the next one, he explains why our study is important, because in India, most of the people use UPI as the digital payment system, and also millions of transactions happen on this platform. However, the trust is also a main concern, because there is online fraud and technical failure, and also privacy issue. So here, our paper mainly focuses on Gen Z users, not as the UPI users as a whole. So it focuses on how the motivators and demotivators of trust are interlinked. And the literature review is that the first paper is that Venkatesh et al. So here, this paper mainly focuses on how the performance expectancies, which means that how does it help the users, and is it easy to use. But whereas in our paper, it focuses on the just not as how people usually adopt to it. And the next paper is Rogers, where it explains the fear and protection, but where in our paper we have directly connected with how our paper is connect fear directly with the UPI fraud and context. And the next one the next paper mainly focuses on the UPI fraud types and prevention methods. But in our paper, we have shown that how fraud fits into trust hierarchy. So the next one is the research gaps, where we have looked into the trust factors one by one, not as a whole. And because very few papers have shown how a single factor is affected. And the next one is the hierarchy among the trust factors was not studied earlier. So we have integrated that how combining these factors is there. And also ISM and Micmac analysis methods were also rarely used, so we have implemented those methods in our study. And the next one is methodology, where we have identified the problem, which is how the trust is affecting the Gen Z users while using UPI. And we have also reviewed the applicable theories and the literatures. And after that, we have designed a structured questionnaire which we have shared among the Gen Z UPI users, and then we have collected the data. And after collecting the data, we have used two methods, that is ISM, which we have built a hierarchical trust model, and also the other one is Micmac analysis, where we have classified how the trust was based on these factors. The next one is the results and discussion, where the first focus was on foundational enablers, where we have measured the security measures and also how the regulatory assurance was are among the strongest trust factors. And the next one is functional utility, where the speed, reliability, and also the ease of use are convenient and makes the UPI a better platform to be used. And also the evaluative logic, where there is a data transparency and how it can prevent the potential risks. And risk inhibitor, where the fraud concerns are seen, and also how the fear of fraud can take the trust of that platform. And the social outcome is that how these peers influence, and also how they only work after basic trust is formed. So the next here we have given the Micmac analysis and also the ISM hierarchy theory model, where the Micmac theory focuses on how the trust factors are based on the driving power and the dependence power. Here the Micmac analysis is divided into four quadrants. As you can see, the first quadrant is independent drivers, where security and regulatory assurance are seen, and the next one is the linkage factors, and the next one is dependent factors, and the last quadrant is autonomous factors, and where the minor factors are influenced. And here in the ISM hierarchy model, it shows three different kinds of levels. So, firstly, the bottom level shows how the security measures and regulatory assurance are uh, used for the trust formation, and also in the middle level there are factors like speed, ease of use, data transparency, and how the past experience also helps. And also in the top level there is peer influence and rewards and gamification. So trust here, the trust basically starts with the safety on how easy it is for the users to use the platform, and then grows with the performance, and then how it is sustained. The next one's a conclusion where the trust in UPI starts with the basic rules and how it is easier for the user to use, and also once they feel safe and their data is confidential, then it might be easy for them to use, and also how the trust is reinforced through social influence and rewards. The next one is we are thinking to expand this research for not only to Gen Z users but also to millennials and the Generation X, how it differs from the study which we have made now, and also how how new UPI features will impact this study, like the UPI Litex and also the credit on UPI. And if we combine ISM with other statistical modeling like SEM, which means the structural equation modeling, and how it strengthens the relationship, and also how the platform specific dynamics are. So these are the references which we have studied and taken from. Yeah. Thank you.
I request respected session chair, sir. Sir, do you have any questions?
Uh, is there any specific data set available for Gen Zs?
So we have created a questionnaire and we have circulated among the users, and then we have collected the data, sir. There's
So you
no
prepared it,
specific
right?
data set. Yes, sir.
Yeah. One more question actually I had, but you cleared this in your future work. Why Gen Z users? Okay,
Okay.
that is clear to me.
Yes, sir.
This one suggestion to you, in literature survey and in the references, I can see old research papers.
Yes,
So
sir.
try to utilize research papers from 2023. Max limit you can set it to 2021. So
Okay, sir.
latest research paper, latest methodologies you can refer always.
Yes, sir.
Okay.
Thank you, sir.
Thanks.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call presenter Sahil Dubey for the paper title Analyzing Construction Project Delays Using Data Analytics. I request the presenter to kindly proceed with their presentation.
Good afternoon, one.
Yes, sir, you can proceed with your presentation.
Sir, can you see my PPT?
Sir, we cannot see your presentation, but we can see your folders.
Give me give me a minute, sir.
No problem.
Sir, right now, can you share my?
Yes, sir,
See my
we can see your screen, but currently your Zoom window is open. Kindly shift to the presentation.
Sir,
Yes, sir,
right
now
now?
it is visible.
Yes,
Please
sir.
proceed.
Yes, sir. Firstly, my name is Sahil Dubey, and I am doing MTech in Parul University, Vadodara, and my co-author name is Hiral Patel. Firstly, my topic name is Analyzing Construction Project Delay Using Data Analytics. So, firstly, introduction. In India construction sector drives infrastructure, employment, and productivity supported by major programs like the National Infrastructure Pipelines using $1.4 trillion. However, present schedule delays and cost overruns with 779 project delays and 501 lakh crore in overruns MO SPI 2024. Undermine value globally, construction remains large but underperforming with mega projects, especially at risk. The study analyzing delay causing using a data-driven multi-stakeholders approach combining frequency and severity index FI and SI to compute relative important index RII scores and test group differences statically. The goal is to identify high impact delays factor and provide actionable insights for improving planning, governance, and project performance across India infrastructure pipeline. Construction delay are the major issue in India. They lead to time and cost overruns. The study applies data analytics for prioritization. Construction delay are major issue in India. They lead to time and cost overruns. This study applies data analytics for prioritization. Objective of the study: identify major causes of delays, rank factor using RII method, apply INNOVA method, analysis of variance, suggest solutions. Second page, objective of the study: analyze factor affecting construction project delays to evaluate the effectiveness of data analytics in identifying, mitigating, and managing delays in construction project. To study the effect of delays in construction project, time overruns, cost overruns, dispute abandonment. To determine way or statistics to reduce delays in construction project, to assess and analyze factor contributing to project delays, client, contractor, consultants, material, labor, and external things, to identify the major causes of delay in construction project, to investigate the relationship correlation between causes and effective of delays, to compare perceptions of different stakeholders like client, contractor, consultancies on other delay factor. Problem background: for frequency schedule slippage in construction project, approval of labor, equipments, material are key issues. Need for data-driven decision making. Research method: survey of 110 professional to use questionnaire method, 5 point like scale, quantitative mono method, cross sectional study, and second tentative methodology. Firstly, I am studying research design, and second data collection, third sample method, fourth one is software and analytic tools, fifth one relativity and validity testing, ecological consideration, conclusion and recommendation. Summary of literature review: key causes of delay, planning and scheduling issues, inadequate planning, poor work sequences, weak supervision, and unclear project scope. Chin and Amman, 2015, Smith at AL 218, Zone as Smith 2016. Resources constraints, shortage of material, shortage of labor, equipments, and skilled labor. Financial problem: delayed in payment by owners, insufficient funds in case of contractor financing, and cost estimation. Design and documentation error: frequent design changes, rework, and incomplete drawings. External factor: weather, inflation, policy changes, and poor regulatory control. Impact of delays: cost overruns, time delays cost always result in additional cost. Quality and safety risk: poor time control effect construction quality and work safety. Stakeholder relation: delay cost dispute, arbitration, litigation, and loss of contractor reputation. Project failure: serve delay may lead to abandonment and termination. Mitigation strategies suggest proactive risk management, early identification of risk, stakeholder collaboration, time decision making through coordination, technology adoption, use of BIM, project management software, and predictive analysis, improve documentation and record keeping, transparent monitoring to reduce dispute, research gap, limited cross-country computed study on causes of study, lack of empirical validation of digital tools, BIM, AI, predictive analysis in construction reduction, insufficient research on sectional
variation, public vs private residential infrastructure. Few study on the long-term impact of delays on contractor performance. Research and the aim of the study is to identify, evaluate, and analyze the critical factors contributing to time overruns in construction project and to assess the effective of the time management and practice and delay analysis technique in mitigating such overruns. Scope of work, data collection, conducting structure questionnaire, interviews, and case study with stakeholder, including project owners, contractor, and consultants across selected construction project. Data analytics, applying distributed and inflated statistical tool, example mean standard deviation, innova e and ova, analysis of variance to evaluate frequency and severity of delays, evolution of delay analysis method, comparing techniques such as critical path method, time impact analysis TIA, as plan VI, VS as build similar models, and forensic delay analysis. Identification of key factors, categorizing and prioritizing cause of delays under client relation, contractor related, consultant related, resource related, external factors. Impacted assessment, study the consequences of the different overruns on cost escalation, distribute project appointment, and stakeholder relationship. Mitigation strategies, exploring effective project management, practicing technology adoption, BIM, AI, digital tools, and collaborative approaches to minimizing delays. Case study and validation, presenting real-world example, lessons learned, and success story to validate finding and recommendation. Data analytics framework, frequency index FI denoted by FI, service servability index denoted by SI, relative important index it is denoted by RII. Innova analysis. Innova analysis
Sorry
is
to interrupt,
denoted.
sir, but you have 1 minute to conclude.
Ji, sir. Top delay factor, design approval delay 53.0%, labor and subcontractor delay 51.36%, equipment failure 48.1%, unskilled labor and distribute material changes. Top delay factors. Statistical result, Innova, significant variation among delay groups. Result are statically valid. Result as per questionnaire bar chart. Causes of delay in project. Original contact duration is too strong. Legal dispute between various parts. Effective delays penalties. Discussions. Design approval and workforce issues dominate. Equipment relativity effect productivity. Material changes cause rework. Recommendation: faster approvals, skilled labor training, preventive maintenance, better subcontractor management. Conclusion: RRI, reflecting important index, helps prioritize delay causes. Data analytics improve decision making. Support timely project delivery. Thank you.
I request our respected session chair, sir. Sir, do you have any questions?
Actually, how you are evaluating delay analysis?
Yes, sir.
That is not mentioned. You have just mentioned the point, but how you are evaluating delay analysis?
Firstly, sir, I am collecting the data in field in a questionnaire, and I have I have some delays factors.
Okay.
So shall we proceed further?
Yeah, please.
So we have one extra presentation in this session. So for the presentation, I like to call presenter Ritu Soren for the paper title Integrating Artificial Intelligence for Ethical Decision Making in Engineering and Interdisciplinary Analysis of Ethical Parameters. I request the presenter to kindly proceed.
Good afternoon. Am I audible, sir?
Yes, ma'am, you're audible.
Okay, I'm going to share the slide. This is visible.
Ma'am, yes, ma'am, it is visible to us.
Yeah, thank you. Yeah, good afternoon, all of you. Good afternoon, sir. Sir, I am Dr. Ritu Sauryan.
Yeah, good afternoon, madam.
Yeah, I'm Dr. Ritu Sauryan, professor at Dronacharya Group of Institution, Greater Noida. And it is truly an honor to be here today. I extend my sincere gratitude to the SMARTCOM organizing committee, the Springer publication team, our esteemed session chair, and all distinguished participants here. Uh, Today, I'm delighted to present my research title, Integrating Artificial Intelligence for Ethical Decision Making in Engineering, an interdisciplinary analysis of ethical parameters. With over my 25 years of experience, I'm going to complete 25 years. Uh, on 18th March itself in 2026. So over my 25 years of academic and research experience and more than 40 national and international presentation, I must say this presentation is special for me. Because it is special because this work is closely connected to my postdoctoral research on artificial intelligence and ethics, which I'm doing from Singapore, and it represents a meaningful step forward in that journey. That even the people, those who are from humanities background, they also can do something and provide something good for the society, which is good for the long survival on the earth with a healthy lifestyle. With your kind permission, I now try to explore through this PPT. Like slide
Please go
number
ahead, ma'am.
2, which is visible to you, I think. Yeah. See, today's artificial intelligence is no longer just a tool. People feel like that it's a tool, but it's no longer, it's not a tool only. AI is becoming a decision maker, and AI decides who gets shortlisted for a job nowadays. And AI is doing that much that we receive a bank loan through AI, and even who gets priority in medical care, we get it through AI. So today the real question is not can we build AI system, but the real question is can we trust them? Because trust is a big question that people try to find out the answer even through humanities background. So, and this presentation focuses exactly on that, how to design AI systems that are not only intelligent but also fair, responsible, and trustworthy. Because we deliver and talk a lot, but whatever we are doing, actually we are implementing or not. It is visible in our actions or not. That is, if you observe the slide number, this slide, yeah. If you observe this, so you may see the hidden problem AI. Hidden problem is AI depth. Hidden problem. This is the, risk concern I talk about. Like we employed a systematic qualitative review methodology, which is actually clearly defined, inclusive, true criterias over 30 global AI governance and accountability framework through thematic coding. Because, my colleagues, those who work with me on this paper, they are from technical background and I am from humanities background. But because I have a depth knowledge about human values and professional ethics, and I work a lot and deliver so many things, so this thing add on value to the technical sounds field. Each framework which was evaluated here on the dominance, the depth recognition and quantification, which revealed a critical gap and the absence of mechanism to track cumulative ethical risk over time, which that our proposed DADM team framework directly access. That when we have a look at DADM, DADM framework, that is actually, this is the framework that directly addresses the issue. Let me introduce a very simple but powerful concept. Uh, as engineers, I'm not talking about myself, about the engineers. As engineers, we all understand technical depth and we understand it very well. And if I have assumptions, so people try to understand the technical depth at first. When we take shortcuts today, now the issue is there, we pay for them tomorrow. If we take the shortcut today, even in our personal life too. If we take the shortcut, then we pay for it for tomorrow. Now imagine a debt that affects. Debt affects not only the people, but also the society. And it's raised a big question mark on trust, public trust. That's the question. So this is what we call AI debt. This is we call AI debt, because nowadays people have different concerns that AI is going to be dangerous for all of us, for human beings. But who is the creator? Human being. Human being, they have developed brains. So AI debt grows when bias in data is ignored and ethical decisions are postponed. That is, AI debt grows. That this thing grow and systems are deployed with long-term thinking like financial debt. So AI debt grows silently, but for this we people need to work on it, but become extremely expensive later. We know about it. So when we have a look at the slide, then we can understand it. See, AI debt has three deeply interconnected forms, which we have: ethical debt or social debt. Basically, technical debt that is related with the poor data quality and weak models. That rush the engineering decisions and which is very harmful. And ethical debt, when we talk about when technical flaws starts causing unfair and biased outcomes. So this appear when we have a look at the social debt, then we may observe this appears when people lose trust in AI system. And when people lose trust in AI system, once trust is lost, then it is extremely difficult to rebuild. I can say impossible to rebuild. That is still the people have a question mark on it. So why is AI debt increasing? And what is the reason behind it that we people are not able to take care of it? That's silent accrual of interest that we people should be aware about it. That you might ask, why is the problem growing so rapidly? What is the reason behind it? Our research try to identify the several reasons. Pressure to innovate faster. If we people far from this thing, then we can do something actually, outcome based. Because on paper, if we are doing outcome based, but actually it is not visible in action, so this thing is useless. So pressure to innovate faster, this is the reason. This is one of the reason I can say as per the research. Or lack of structured ethics training. If people have lots of degree, but they don't know how to implement the things, if this is not visible in their behavior, so this thing is useless. Everything is useless. Even the degrees, they are useless. They are only a piece of paper. So unclear ownership sometimes create a problem. If ownership is not clear, people cannot give their best. A culture of just make it work. If this thing is there continuously, so most developers are not unethical, I mean to say. Most developers, they are not unethical. They are unsupported by the system. That is why these type of fears are there in the market. And that create a fear, and we people cannot survive for long on this earth. The problem is not intention. The problem is design. If I talk about related to only specifically the PPT or the research. So basically, what is missing actually in AI ethics? We can say basically the missing concept. Missing thing is that we analyze, more than 30 global AI governance frameworks. Not me alone, my co-authors and one of my professor, he's from Singapore. His work is really immaculate. And even two of my students, they work a lot because they are from AI and CSIT backgrounds. So they, their guidance. I cannot say that I have 25 years of experience, so my competence is high. Sometimes our students give better than us. So we analyze more than 30 global AI governance framework, and they all talk about fairness, transparency, and accountability. But here is the limitation. Most framework ask, did you consider ethics? Most framework, they ask, did you consider ethics? So they do not ask, how serious is the risk? They do not ask about it. Or is it increasing over time? Or when should deployment stop? So ethics is discussed. It is not being measured. We cannot say it is being measured. Yes, of course, in professionalism, we may observe the behavior of a human being. right? Because nowadays, if we ask the biggest fear on the earth, a human being is the biggest fear on this earth. Now, the point is there that how we people have to work and how we can quantify this thing. That the static trap is there. This creates what I call the static trap. That is basically ethics become a one-time checklist at deployment. When we, just like as a teacher, when I prepare all the things and when we deploy, something is little bit different, right? But planning is there. So, but unlike software updates, ethics risk did not.
I'm sorry to interrupt, but you have
Yeah.
1 minute to conclude.
Yes, sir. Just I finished up. So they, when we talk about when unchecked AI system enter an AI death spiral driven by speed to market pressure, and this thing create a problem. So once inside this spiral, system becomes rigid and it's become expensive and socially fragile. So we have to work on it. The solution, DADM framework, to address this gap, we propose the dynamic accountability depth matrix. Dynamic accountability depth matrix. And then when we say to address this, it allows the organization identify ethical risks, and it is very helpful to measure and monitor them continuously and fix them before the problem arises. So DADM works. DADM evaluates AI system across 3 dimensions: ethical principles and life cycle stages, and with the help of different types of dApps. That's we through the theoretical part. So this is the most powerful contribution. Ethics become measurable because this will help us a lot. Each risk is scored from 1 to 5. Minimal risk 1, 5 critical ethical danger. So we may now ethics become visible, now ethics become auditable, and now ethics become actionable. So individual scores are aggregated into total fairness depth. Total fairness depth. Total AI depth, I can say, can be heat maps, help leadership. People love to work with people, not on them. Thought process will be changed. See, ethical, healthy, instantly take informed decisions, and it is very helpful for us. That KRIS I have used there, that act early warning signals that we receive through it, that predict ethical failure, and it is very helpful to avoid the crisis. And basically, ethical refactoring is deployment. If risk exceed, deployment stops, and data is corrected on time, and the model is retested. Only then does the system move forward. And this is ethical engineering in action, I can say. Or basically, this research is the result of the collaborative academic research, academic efforts. I am from humanities background, and my colleague, they are from technical background. And sincerely acknowledge Professor Balakrishnan from Singapore Institute of Technology, and Professor Ajay Kumar, Vice Chancellor of Devbhoomi University, and Professor Kamal Uprati, Christ University, Delhi, Professor. Their insight and interdisciplinary guidance made this work possible. Let me say thank you to all, especially for the students and the young engineers, because their guidance and their support to me to help me out to work on this with my, researchers. And the goal is not just to build powerful AI. The goal is to build AI we can stand behind with confidence. And when we, manage AI depth wisely, we do not just, build better technology, but we build a better society. And I hope this presentation encourages us to rethink. And thank you very much for your time, sir. I look forward if you have any suggestion for further studies. Thank you.
Thank you, ma'am. I request respected session chair, sir. Sir, do you have any questions?
This is very nice presentation. Nicely started this presentation actually. Well said. AI is not just a tool now.
Yes, sir.
You are very good with your goal. Wish you all the best, Dr. Ritu, for your postdoctoral program.
Thank you, sir. Thank you so much, sir. This thing
Yeah.
matters a lot for me. Thank you, sir. Because this
Yeah,
field, I'm working in a different field. Thank you. Thank you, sir.
Thank you, ma'am. Thank you, sir. Now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the ninth versions of the previous conference. We'll be happy to have you in 11th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I also thank our session chair, Dr. Joshi, for chairing the session. Third is a token of appreciation and love from SmartCom 2026 team and Global Knowledge Search Foundation and partners.
Thank you, sir. Thank you very much.
Thank you, sir, for your valuable time. Now, I request everyone to kindly turn on their cameras for a quick virtual snapshot. I request everyone to kindly turn on cameras for a quick virtual snapshot. Thank you. Have a nice day ahead.
Yeah. Thank you.
Thank you, sir. Thank you, everyone, for
Thank
your
you very
valuable
much, sir.
time. Let's meet you in 2027.
Thank you, sir.
Yeah, let's meet in 2027. Right. Thank you. Thank you, GR Foundation. Thank you, Springer Nature, and all the participants. Thank you.
Thank you, sir. Thank you, ma'am. Thank you, everyone.